Hi guys, so this is a quick explainer video on key calculation across chapters 1 to 3. First off, let's start off with economic costs. So remember we talked about opportunity cost earlier on, and that is basically a combination of your implicit and your explicit cost. In other words, what are the values of things you're going to have to forego in order to get a particular item, right? So let's take an example real quick. You guys are in class, attending college right now. So what is your total cost of you, choosing to be in school? First of all, tuition. So tuition is going to be among your explicit costs, right? And let's assume that that is $21,000. How about rent? You got to pay for the room you're staying in and all of that. So let's say the room and board is $11,000. And also you got to pay for books, right? So let's say the cost of books is $1,800. All right. So we keep those explicit costs lined up. However, if you weren't in school, your next best thing you'll be doing is to probably work and get paid on the job. How much would you get paid on the job? Let's assume you're getting paid $16,000. Okay. You will still need a place to stay, right? You still need to pay for rent, even if you weren't in school, right? Let's assume that is $7,200. Okay. Notice that in both cases, either when you're in school or when you're not in school, you have to pay for rent. You have either you crash your parents or you pay for rent, right? So let's assume you're paying for rent, house rent. So what you're going to do is you're going to deduct the costs. So you notice that the cost for house rent when you are not in school is cheaper, right? So you deduct this cost from the cost of house rent if you're in school, right? So let's say 11,000 minus 7,200, and that should give you about 3,800, right? So the addition of your tuition plus the difference between your room and board plus your books and your salary gives you your total economic cost, which should come down to 42,600. So economic cost is very different from accounting cost. Accounting cost is basically only equal to explicit cost. It doesn't consider your implicit cost of time or the cost of what you are giving up to get that item, okay? So that is one thing that I wanted to explain here. So the next thing to explain is what we call production possibility frontier, also known as PPF. So remember, this tells you the combination of goods that a country could produce, not should, could produce, okay? All right. And one of the major assumptions of a PPF is you assume that there are two countries. In this case, let's assume US and Japan. You assume that there are two goods. In this case, let's assume airplanes and soybeans. I mean, which one do you think would cost more to produce? Generally, it will be airplanes, right? So let's assume each of these two countries have 50,000 labor hours available. In other words, they decide to use labor as their input. They don't want to use capital. They are solely relying on labor, right? Again, this is just hypothetical. Every country relies on a balance of labor and capital, but this is just a hypothetical assumption. So remember, economics is based off on models that uses theories. In other words, they take abstractions from reality and simplify it so that we understand basic concepts that we can then apply to build more complex frameworks, okay? So now, assume we have 1,000 labor hours and that one airplane costs 500 labor hours. I'm going to call labor hours LH. And then one soybean costs 10 labor hours, okay? So how do we know the opportunity cost of producing any of these, right? So as you can tell, it costs 500 labor hours to produce one airplane. In other words, what is the equivalent of 500 labor hours in terms of soybeans? So that would be equal to 50 soybeans would be the equivalent of 500 labor hours, right? So, I mean, since 10 labor hours produces one soybean, then 500 labor hours will produce 50 soybeans. So in other words, the opportunity cost, I'm going to call it OC, the opportunity cost of one airplane is equal to 50 soybeans. And something you should notice is that opportunity cost of one good is the inverse of the opportunity cost of another good, right? So the opportunity cost of one soybean, you guessed it right, is going to be the inverse. So 1 divided by 50, which is going to give you 0.02 airplanes. So remember, opportunity cost is what you are giving up to produce more of another good. So in other words, you give up one airplane to produce 50 soybeans, right? And then you would give up some soybeans to produce airplanes. Okay, so now, how do we do this in a PPF form, in a shape? We want to give it a graph. So the first thing to do to make it easier is to do a table. So assuming we want to produce the extreme, so only produce one good or the other, right? Assuming you have 50 labor hours. So the first extreme would be 50,000 labor hours divided by 500 airplanes, 500 labor hours for airplanes. And that is going to give you a total of 100 airplanes. How about the other extreme? 50,000 labor hours divided by 10 labor hours for soybeans. That is going to give you 5,000 soybeans. Okay, so your table is going to look something like, let's call airplanes A and let's call soybeans SB. And if you decide to produce any of these extremes, then it's either you are producing 100 airplanes along with 0 soybeans, or you are producing, on the other extreme, 5,000 soybeans and 0 airplanes. Now we got to fill in the gap, right? So assuming we decide, okay, we want to produce a combination of either good, so let's take 40,000 labor hours for airplanes. So 40,000 labor hours for airplanes, remember 500 labor hours for airplanes, that's going to give us how many airplanes? 80 airplanes. And what are you left with if you take 40,000 out of 50,000? You're left with 10,000. So 10,000 labor hours for 10 labor hours of soybeans is going to give you how many? 1,000 soybeans. Okay? We still have some other extremes to fill. So let's say you decide to take 25,000 each. So 25,000 into 500 for airplanes is going to give you 50 airplanes. And you're left with another 25,000 if you take 25,000 for airplanes. You're left with 25,000 for soybeans. Divided by 10, that's going to give you 2,500 soybeans. How do you know if this is a constant opportunity cost or an increasing opportunity cost? Increasing opportunity cost means that to get one of another product, you have to give up more of the other products, okay? So in other words, if it was an increasing opportunity cost, to get more of soybeans, you have to give up more of airplanes. So, but let's check if this is increasing or constant. I'll give up 20 airplanes to produce 1,000 extra soybeans. Or you can look at it as giving up 30 airplanes to produce 1,500 extra soybeans. But basically what this is saying is for each 10 airplanes you're giving up, you are producing extra 500 soybeans. So this is a constant PPF. So this is the constant PPF. And plotting the graph is going to look something like this. Remember the extremes? You start with the extremes, 100 airplanes, assuming this is the axis for airplanes, and then this is the axis for soybeans. So the extremes are you either produce 100 airplanes and 0 soybeans, or you produce 5,000 soybeans and 0 airplanes, right? So this is the PPF line, the constant PPF line. That is why it is straight. If you were giving up increasingly more airplanes to produce extra soybeans, so in other words, this is not constant. Assuming this is not constant, then you would have a PPF that looks like this. Okay, so it will be bowed outward. But for now, this is what we have. Okay, and then to finish plotting your PPF, you would have different combinations in between if you decide to produce both goods, right? So 80 airplanes would go with 1,000 soybeans. Okay, and then 50 airplanes would go with 2,500 soybeans. So something you should note is that anywhere on this curve is efficient. Okay, and anywhere, so let's call this points A and B. So points A and B are efficient. Anywhere inside the PPF is inefficient. And it's inefficient because you are not fully maximizing, your resources. So if you are producing at point C or point D inside the curve, you are underutilizing your labor, capital, money, and other resources, okay? So point C and D are inefficient. How about somewhere here, point F? Anywhere outside the PPF is not feasible, right? So it's not attainable. It's not possible to produce outside the PPF given the resources that you have, okay? The only way you can attain point F is via technology. So technology is the solution to produce outside the PPF on point F, okay? So these are major things to note. Okay, so remember that the basis for trade is opportunity cost. In other words, whatever product you have to give up less opportunity cost is where you have comparative advantage, and that is where you should produce. So let me give another example. It's still very much related to the PPF, but in another format, okay? So let's assume you have two countries, again, still based on PPF, two countries, England and France. And then you have a total of 40 production hours. Total production hours is 40, okay? And you're assuming an equal split an equal split of labor hours between both countries. Now, if you have England using 1 labor hour to produce cheese and 4 labor hours to produce wine, then you have France on the other hand with 5 labor hours to produce wine or to produce cheese, and then 2 labor hours for wine. Okay, so now you want to determine which country has a lower opportunity cost for which good so that you know what to specialize in. Okay, so that means each country has 40 hours to be split equally between 2 goods. So assuming you have 20 labor hours for cheese, so 20 divided by 1 is going to give you 20 units of cheese. And then 20 divided by 4 labor hours is going to give you 5 bottles of wine. Okay? For France, they still have 20 labor hours for each good, right? So 20 divided by 5 is going to give you 4 units of cheese plus 20 divided by 2 labor hours is going to give you 10 bottles of wine. Okay? So this is assuming that they're not choosing to consume at the extremes of the ppf. Okay? So what's the total production for both countries now? 20 plus 4 would give you 24 units of cheese in total and 15 bottles of wine. Okay? So this is how you determine the total production for the countries. Okay, so how do we determine the opportunity cost of cheese and wine? Okay, so the opportunity cost of one cheese is equivalent to saying 5 bottles of wine divided by 20. You want to know how much you're going to give up? So that is equal to 1 divided by 4 or 0.25. So you have to give up a quarter bottles of wine to produce one cheese. How about the opportunity cost of 1 bottle of wine? That's going to be 20 cheese divided by 5 bottles of wine. So that is 4. So you have to give up 4 cheese to get 1 wine. Okay? Or giving up 1 wine will allow you to produce 4 units of cheese. How about France? Opportunity cost of 1 cheese is equivalent to saying 10 bottles of wine divided by 4, which is going to give you 2.5. Okay? An opportunity cost of 1 wine is equivalent to saying 4 cheese divided by 10, which is 0.4. So looking at these opportunity costs for both countries, you can see that England has to give up less wine to produce cheese, okay? And France has to give up less cheese to produce wine, okay? So based on that, England should specialize in producing the good in which they have comparative advantage, which is where they have opportunity costs, right? So England should specialize in producing cheese, and France should specialize in producing wine. Okay? Because the opportunity cost, what they're giving up for wine is less. I want to quickly illustrate how do you calculate total revenue, marginal revenue, total cost, marginal cost. Okay? So if you have price, let's say you have price, you have quantity, let's say at $1, you have the quantity, say 30 units, right? And at $2, let's say you have about 20 units being sold. And then at $1, let's say you have about 5 units being sold. Okay, so this is just a hypothetical example. How do you calculate total revenue? So total revenue is simply going to be price times quantity. So $1 times 30 units that are sold gives you a total revenue of $30. $2 times 20 units that are sold gives you a total revenue of $40. And then $3 times 5 units that are sold gives you a total of $15, right? So you can see this is a very elastic good because it's you can see that the higher the price, again it follows the law of demand, the higher the price, the lower the quantity that's demanded. And what that means is that consumers are very responsive to changes in price. So this is elastic, right? So you can see that for an elastic good, the higher the price, the less the revenue, the less the total revenue, okay? So now how about marginal revenue? So marginal revenue is just like the difference in the total revenue. Okay, so the first value is not going to have anything, but what is the difference at the price of $2? What is the marginal revenue? $40 minus $30 gives you $10. So they made an extra $10. They made an extra $10 in the revenue. Okay, and at $3, what is the at this point, they're pretty much making a loss. So $15 minus $40 is going to give you minus $25. So this is a loss, right? Okay, so now that is that for marginal revenue. So marginal revenue is just the difference in the total revenue. How do we calculate total cost? So total cost is a combination of your fixed cost. Your fixed cost is basically whether or not to show up to work, you're going to incur that cost. So for instance, if you have a store for your business and you're going to pay rent for the store, you're going to pay utility bills for the store, right? So all of that is under fixed cost. Then variable costs are things that you incur on a day-to-day basis. So let's say in paying your workers or in buying the supplies needed for the business, right? Buying the raw materials needed for the business. That is under variable cost. So your total cost is a combination of your fixed cost and your variable cost. So let's assume that in producing 1 unit of a good, you spend $3 for your total cost. In producing 2 units of a good, you spend $7, right? In producing 3 units, you spend $10. 4 units, you spend $13. 5 units, you spend $15, right? So now we know the total cost. How are we going to calculate the marginal cost? So the marginal cost, because there's nothing, basically at the quantity of 0 units, you have $0. So basically your marginal cost at this point would be like $3, right? Because that's the difference between when you produce 1 unit and when you don't produce any units, right? Okay, so at the quantity of 2 units, what is your marginal cost? Your marginal cost is just the difference in total cost. So $7 minus $3, that's going to give you $4. That's your marginal cost at 2 units. At 3 units, your marginal cost would be 10 minus 7, which is $3. At 4 units, your marginal cost would be 13 minus 10, which is $3. At 5 units, your marginal cost would be 15 minus 13, which is $2, right? So do you see how the extra cost reduces as you produce more units of a good? And this is illustrating something we call economies of scale. So economies of scale just means when you produce things in bulk, it's cheaper, right? So it's cheaper to bulk sell or to bulk buy, right?